Ok, buenas tardes, buenos días, mis estimados aprendices. Mucho gusto, espero que estén todo bien. Hola.
Hi, Mister. How are you?
Hi. Good, good. Aquí que
Can you
tengo
help me with one from the homework, please?
Yeah, I know. Someone's asked me for about the homework. Okay, let me tell you what we're going to do. We're going to discuss at least the four exercises of the classwork, and after that, we are going to give you some time to you can start working with the homework. Okay. And when you have doubts or questions, you can project in the screen and let me know what are the questions. All right. But first of all, we're going to discuss the classwork. Okay. All right. Let me change the camera view. We have only 8 students. Solo hay 8, 7 alumnos en casa. Pucha. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Más 7 son 21. Ustedes son 24, ¿no? Estoy faltando. Es que aquí hay 7 en casa. 7 en casa, por eso le digo. Bueno, ya se trabó esta cosa. Pues sí, pero le digo son 21. Ok, let me pin my video. Shh. All right, class, please. Okay. All right. Let's going to discuss the classwork number 1. And after that, we're going to working with the homework. Okay. Go right ahead. Go right ahead. Okay. Classwork number 1. This is basic math. Well, actually, to tell you the truth, the basic math, the only thing that we have the basic math is the name. But basically, this is pre-algebra. Basic math, classwork number 1. Okay, let's going to discuss or let's going to solve the first classwork. Okay. Um. Okay. In the first problem, or the problem number 1 says, we have a club is scheduling. A club is scheduling. It's scheduling a week of meetings. A week of meetings. Okay. To plan for his annual. To plan for his annual fundraiser from fundraiser. Fundraiser, period. The club wants to meet the club wants to meet on 3 of the evenings next week. Period. Next week. Oh no, coma es la cosa. Comma, from Monday, through Friday. Good Friday. And the question is, how many different schedules can the club choose? Okay, that was the first problem. Okay, let me approach the Zoom camera. Okay. And as soon as you can read in the whiteboard, we're supposed to plan a minutes of time, 3 minutes the entire week. In this problem never specify what kind of meetings we're supposed to have. If there's a priority for 1 meter, that meeting a priority for another one, something like that. The problem says, okay, we have to planning 3 minutes around the week. I mean, since Monday to Friday, there is no priority order in that situation. And for that reason, because the order doesn't matter, we're talking about the combination problem. That's why the moment when to apply the combination, the first thing that we must identify is the n's in our factors. The n value will be 5 because you're talking about the 5 days of the week. Monday, Tuesday, Wednesday, Friday. We have 5 days. And the letter R represents the 3 meters that we're supposed to arrange in this situation, right? And because we are looking for the combination, we can say, okay, this is going to be the combination 5C3, right? That will be given by 5 factorial over 3 factorial parentheses 5 minus 3 factorial. All right. In simple merely words, 5 factorial is the product recursive since the number 5 until the number 1. I mean 5, 4, 3, 2, 1. Actually, this point at the middle between the numbers are represent like a product symbol. But if you want to use 5 in the X like a product symbol, don't worry, it's the same. 3 factorial is 3, 2, and 1. Multiplying by 5 minus 3 is 2 factorial. Okay, 2 factorial is 2 and 1. If you see, 3, 2, 1 can be canceled with 3, 2, 1. And 2 times 1, 2, 4 divided by 2 can be canceled, and that will be 2. So 5C3 equals 5 times 2, because 4 divided by 2, correct? 5 divided by 2 is, 4 divided by 2 is 2. So 5 times 2 will be 10. And this is going to be the solution set of the first problem. Okay? No big deal, no situations. Question to this part? No? Sorry. Excellent. We have the first answer. Let's go to copy the second one. In the second one, this is an explanation. What does that mean? An anagram. An anagram. An anagram is a arrangement. Is is a rearrangement. Is a rearrangement of the letters in a word. In a word, okay? From another word. To form another word, period. For example, okay, for example, for example, an anagram of a stop is post. Is post. Period. Letter A. How many arrangements? How many arrangements How many arrangements of the letters R-A-T, of the letter R-A-T are there? That will be one question. And another one is, what is the probability what is the probability that a random arrangement there's a random arrangement of the letters in the word rat in the word rat will be anagram of rat. Okay, that was the problem number two. The problem number two can be considered just like a shortcut or basic shortcut of a permutation, but you don't need to calculate the permutation. The only thing that there's two ways we can solve the problem. The longest way is prepare a list of the words. For example, the first one is rat. Do you mind to tell me the second arrangement? Excuse me? Tar. Okay, tar. Another one? Car. Art, sorry. Art. Uh-huh. Tra. Okay. A-T-R. Uh-huh. A-T-R. And A-R. R-T-A. R-T-A. Okay. So as soon as you can see, my dear students, how many arrangements do we have? That will be six, right? The number arrangement will be six. For that reason, because we really need to know what will be the probability will be the number of events divided by the total events. And because we are taking one singular word divided by the total words that we're supposed to arrangement, that will be one word is rat over the entire list. There will be six. Okay. This is the solution of the problem number two. But just in case you said, I'm having hard time trying to figure it out, how we can create this arrangement. Well, there's a mathematical solution also. How many letters do we have in the letter A-R-A-T? We have three, right? No, I'm just using the letter A-R-A-T because it had rat. Rat has three letters, okay? And because we are looking for the number of ranges, the only thing that you have to do if you don't want to create this list is apply the concept of factorial. Instead to copy number three factorial. What does that mean? Three factorial is the recursive product of the numbers since the number three onto the number one. I mean, 3 times 2 times 1. So you know, 3 factorial will be 6. This is another way of solving the part 8. Yeah, both of them. The red one is the longest way. The red one, okay? And the green one is the shortcut, as a matter of speaking. Both ways are acceptable because R-A-T, we have 3 letters, okay, to factorial, the answer will be 6. And you can check that mathematical process using this arrangement. And you got 6. And the letter B is 1/6. There's nothing we can discuss in the number 2, in the letter B of the number 2. Okay, let's read the number 3. I'm going to move the camera just a little bit to the right side, okay? Yeah, okay, that's okay. All right, in the problem number 3, it has, a school has 100 students. Yeah. 800 students, okay, period. A survey, a survey of a random sample a survey of a random sample of 80 students finds that 48 students enjoy swimming. Enjoy swimming. The question is, predict, interesting question, the total number of students in the school who hate who hate swimming. All right, hate swimming. All right, there just answer the problem number 3, my dear students. We have a lot of ways how we can perform this situation. For example, at the moment I'm going to calculate the value from P. Remember, we're supposed to apply, the letter P will be divide the survey divided by the random sample, right? Okay, I'll do it in this way because in this case, they're asking for the quantity of people who hate swimming. Simple. That survey gave us 48 of 80 students who love swimming, right? So if you really want to know how many students hate, hold on, 48 of 80. So I mean, 48 loves. So in numbers, we're talking about 52 people hating swimming, right? Yes or no? No, no, a ver. 48 para 80, mientras son 32, ¿verdad? 32. So we can use 32 students instead to use 48. I'm going to use 32 because 32 students hate swimming. Divided by the random sample 80. Okay? You can leave this answer in fractions or in percentage. Both answers are acceptable. Now we're going to calculate the prediction. Remember the prediction, that's supposed to be X equals P% parentheses population. Okay, so P% I'm going to give you 32 over 80. Okay, and what is the value of the populations? The value of the population, we're talking about 800 students. All right. Basically, if you divide 800 divided by 80, that will be 10, right? 32 multiplied by 10 students. So the value from X will be 320 students. Remember, there's a few many ways how we can solve this problem. Another way of solving is one calculating the prediction how many students love swimming, and after that, subtracting 800, or if you wish, with the percentage of P, subtracting from 100, we got another percentage, and we had that answer. So it doesn't matter which way you're going to choose. At the end, the answer will be 320 students who hate swimming. Okay, that what does that mean? That means 480 love swimming, right? Because if you subtract this quantity with this one, we have 480, and that will be the people who loves. But the question is the people who hate swimming. Okay, and finally, the number four is obviously the same thing in the problem number four. Because in the problem number four, we have you're supposed to you have a bag. You have a bag of 40 jelly beans. Jelly beans. Period. Okay. Sorry, comma. There are 5 black jelly beans. Period. The question is, how many do you predict? How many do you predict will be black? I know I said black, but I was missing the letter A. Black uh, in the in a bag of 140 jelly beans. Okay. Well, actually, they're asking for how many will be black. Okay, it's simple. What we're going to do again, we can calculate the percentage. I think once again, survey divided by the random sample, 5 over 40. 5 over 40. You can do it. You can leave this answer in fractions or decimals or in percentage. Actually, I can divide 5 divided by 5, that will be 1, and 40 divided by 5, that will be 8. So I'm going to use P equal 1/8. Okay. Now let's going to calculate X. X, remember, that's supposed to be equal the P percentage times the population. Okay, so P percentage, I'm going to use 1/8 multiplying by the population. We supposed to have 40, right? 40 jelly beans. So, no, this is not 40. 160 is the, porque puse 140, déjeme ver, copié mal. Oh, 160, sorry. 160, my mistake over here. 160, and this is 160. Sorry. And 160 divided by 8 obviously will be 20 jelly beans. And this is going to be the solution set of the classwork number 2. Questions? Preguntas? Nope. Perfect. I don't know if someone who wants to take a picture and send this by the WhatsApp group, please. All right. Because there is no more questions with the classwork, you asked me some questions about the homework. I don't know if someone who wants to share the screen and tell me what is the dot. Excuse me? Yeah, go right ahead. All right.
I can share the homework if you want.
Yeah, please go right ahead. And please, hágale un poquito más cerca porque no miro, no veo, no veo, no veo nada. O sea, hágalo más, approaches the Zoom porque no veo. ¿Ah? Yep. Ajá. Okay. Okay, this bag contains 3 red marbles, 4 black marbles, 4 blue marbles, and 3 yellow marbles. You randomly drop a marble from a bag. What is the probability that drop a red or blue marble? Oh, okay. Okay, this is the number 1. The number 2, okay, sorry, the city. Okay, do you mind to move the number 3, please? Puede mover para acá, ¿sí, no? Ok, vamos a ver, para León, this joint overlapping, this joint overlapping. Okay, perfect. And probably the question is in the number 1, I guess, right? Huh?
Yeah, number 1 and 2. I'm like, I
Okay,
know the formula for the probability, but just like applying it.
okay, let me read the problem. Okay, we have a bag contains, okay, we are talking about the problem number 1. Okay, guys, please pay attention. And the problem number 1 says, we have a bag that contains 3 red marbles, 4 black marbles, and blue marbles, okay? And 3 yellow marbles. All right, this is and according to the situation, you randomly drop a marble for a bag. And the first question is, what is the probability that you drop a red or blue marble? So I have a question for you. If you take a red or blue marble, is this disjoint or overlapping events?
It's overlapping because you don't put back the marble you get.
Okay, remember what is the difference between disjoint and overlapping?
Disjoint is when the action of a thing doesn't.
Overlapping, remember, overlapping is, or disjoint is exclusive events, right? There's nothing in common, all right? And disjoint we supposed to have a event who has in common. So I have a question for you.
There's no.
Is there's inconvenience if you take a blue or red one?
I think there's. It's disjoint. My brain is mush.
Okay, we're talking about marbles. So if you really want to play marbles with your friends, is there a difference if you take a blue one, red one, green one, something like that? No, right? So marbles are marble, but it doesn't matter for that reason. This is if you're taking a root or a blue or red marble, there's nothing gonna because one color is in one color and red color is a red color, right? For that reason, the event will be disjoint, right? Will be disjoint because there's nothing in common. So what it doesn't matter. Marble is a marble, right? But at the red color, there's nothing in common with the blue color, right? So remember, at the moment I'm going to apply that probability. Remember the probability. Well, actually, the first question is disjoint, okay? The second question is find the probability that you drop a red marble. Okay, do you mind, Maria Fernanda, to close the share screen because I'm going to move the camera a little bit to the right side and give you the explanation. Okay, remember in the first case, we conclude in the letter A is disjoint, disjoint. Okay, because I know both are marbles, but what is in common? Red, blue. Red and blue is totally different, but it's the same marble. But for that reason, because we're talking about the same marble, I'm not saying this is going to be an overlapping. Okay, because red is totally different than blue. Now, in the letter B, they're asking for the probability you're going to take a red marble, right? So remember, they're talking about the PA. Remember, probability will be the number of events divided by the total of the events. I mean, how many marbles the problem said you're going to take? One red, right? Yes or no? Yes or no?
One red and one blue.
Okay. Now, red in the letter A says, let me read again. Como decía, red or blue or only red? In the first question, in the second question.
The second question is find the probability you draw a blue marble, and the
Mhm.
third question is find the probability you draw a red or a blue marble. So
Oh,
it's
okay, 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 okay. In the first question is red. Well, blue, blue. You said blue. Okay.
no, Mister. The first one's red. The first one's red. The second
Okay. Okay. The first one is red. Okay. Red. Now, do you mind? Would you like to tell me? We have red marbles. The problem says, oh, okay. We have how many marbles do we have in the bag of red?
just red. There's three marbles, but there's
Uh-huh.
three marbles, four black
Okay.
marbles.
Okay. Let me give the list. Three red. Uh-huh. What else? Three red. What
Three,
else?
four black,
Okay,
four
three.
blue.
Okay, three black.
No, four black,
Okay, four black. Uh-huh.
four blue,
Two blue.
four,
Four. Okay. Uh-huh.
and three yellow.
And three yellow. Okay. Remember what is the concept of the probability? We're supposed to have the number of events of the number of events divided by the total of the events. Okay, if you're thinking, okay, because I'm taking one red and the total of the bags will be, at the beginning we had three red, the probably will be 1/3. If you're thinking that one, you're wrong. Why? Because we're talking about the entire bags of marbles, okay? So would you mind to tell me how many marbles do we have in this situation? How many marbles are so located over here? We got 60, 14, right?
Yeah.
14 marbles. All right. This is the total quantity of numbers that we supposed to obtain with four marbles, right? So this is that number of events. And the first question says, okay, how many in red? Okay. And after that, how many in? How many in red, blue? Okay, black or yellow. Well, actually, as a matter of speaking, if I said one singular color will be one red divided by the, if we're taking the consideration for this probability will be divided by the 14 marbles, as a matter of speaking. Why? Because it's the number of events divided by the total of events. If the question, do you mind to share the screen once again, please? Let me check the answer, the question again. Mhm. You draw a red, yeah, a red marble. You have a blue marble, probably to draw the red or blue marble. Okay, that's the question of the first one, because we're taking 1/14, and the second one is the same. because you're supposed to drop a blue marble. What are we going to do? But simple. We're going to take the one singular marble, a blue marble, divided by that total of marbles that we're supposed to have. Okay, so in this case, in the letter B, in the letter C, it's the same. All right, that will be probably be, that will be, um, that will be a 1 over, let me see it, two. All right, no, 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 permítame, sí, 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 uno azul, ¿no? Vamos a ver, hay 14, sí, uno sobre azul, es uno sobre 14. Vamos a ver, pero se habían tres. No, tienen razón. Aquí en la probabilidad 1, aquí tendría que ser uno de 3. Disculpen. Tenían razón, es uno de 3 rojos. Porque solo habían 3 rojos. Aquí, miren. Aquí uno de 3 rojos, tienen razón. Aquí uno de 3. En este otro, como es uno, ¿cuántos azules hay? ¿Cuántos azules hay? Hay 4, ¿no? 1 sobre 4. Y por último, porque esto viene siendo la probabilidad de que nosotros cojamos uno azul, ¿verdad? Uno de 4. Y la parte de cuando dice encontremos una probabilidad en que nosotros pues cojamos un red en un blue. Ah, ok. Dice un rojo, verde, no tiene razón. Entonces tenía razón María Fernanda. Esto al principio no es un disjoint, es un overlapping. Tenía razón, mija. Tiene toda la razón. Al principio es un overlapping. Bueno, tenía razón. Sí es un overlapping porque independientemente del caso que sean diferentes colores, al final es una canica, ¿cierto? Entonces tiene algo en común, tenía razón María Fernanda. Entonces, ¿cuál es la fórmula de overlapping? Recordemos que es probably A or B, that will be equal to probably A plus probably B, and that's supposed to be equal probably A and B, right?
Yeah.
So in the last one, the probably A, we have 1/3, okay? The second one will be 1/4. In the last one, that will be 1 over 14 because you're supposed to take one red or blue, right? One red or blue of what? Of the entire bag. And how many marbles do we have in the entire bag? In the entire row? That will be? No, that will be 1 over 14 because red or blue of the entire bag. So what will be the answer? ¿Alguien que me ayude? Ok, un tercio más un cuarto. Estos serían 12, 4 más 3 menos 1 sobre 14. Sería 7 sobre 12 menos 1 sobre 14. Y para hacerlo igualito puedo multiplicar 2 sobre 2 aquí para que me quede 14 sobre 14 menos 1 sobre 14. Esto sería 13 sobre 14. Así sería la cosa.
Misa, yo lo hice en calculador y me salió 43 sobre 84.
¿En serio? Un tercio más un cuarto. Sería está
Sí,
mal yo. 3 por 4, 12. Ok.
un
4 por 1, 4 más 3, 7 sobre 12.
no, yo
Menos.
lo hice 1 over 3 plus 1 over
Bueno,
4.
pero simplificado a esto. Y ahora corroboren los demás. Si les da igual. ¿Alguien anda calculadora? Por favor. Un tercio más un cuarto menos 1 sobre 14. Un tercio más un cuarto menos 1 sobre 14. Hay 43 sobre 84. Pucha, que me faltará a mí. Ay, qué lindo. 12 por 2. Miren lo que qué burrada estoy haciendo. Dios mío. Hoy siendo divino. 7, 2 por 12. Estoy poniendo 12 por 2. Ay, Dios, olvídenlo. Es que son cosas de la vida, muchachos. Hoy es lunes. Bueno, ¿cuánto dio? Disculpe. 43 over 84. Sorry. And that will be the solution of the third question. Okay. ¿Estamos?
Yes, Mister. Thank you very much.
Okay. So, bueno, los veo mañana. See, 84, 84, right? 84 or 81? All right. Okay, guys. Thank you so much for your attendance. Have a great, wonderful day. See you tomorrow, God wills.